I want to start with our notes on circles by first talking about the central angles. And so our central angles here in this first section, you can see that this says M arc RU. Well, what that's asking for is the measure of arc RU. And that measure is determined by this measure of the central angle. So we can see that measure of arc RU is 140 degrees. Okay, and so then you can go through pretty simply and find the rest of those. Since this arc is 90 degrees, then that means that its central angle is also 90 degrees. And since this indicates we have 90 degrees, then since they all add up to 360, you can find the leftover there. Okay, so now to this next section, this problem number 2, find the measure of that arc AB. So that would be finding what this central angle is. And so let's see if we can't find what that central angle is here. We want to find what that central angle is there. So the way you're going to do that is by recognizing that this is a radius and this is a radius. And since those are both radiuses, then those are the same. That makes that an isosceles triangle. And since that is an isosceles triangle, then I know that this degree here is 40 degrees. So then you can find what's missing. If this is 40 and this is 40, then and they all add up to 180 because it's a triangle, then this is 100 degrees. So therefore, the measure of arc AB is this angle measurement here of 100 degrees. Okay, so that's all on that one. Now we'll go to the next section where we want to find the length of an arc. So this section can be simply determined by thinking part over whole. If you take care of your part degrees related to your whole degrees, and then you have your arc length, and what would be considered the whole distance around a circle? So how can you calculate this whole distance around this circle? What would that be considered? That would be the circumference of the circle. So that means that right here in this bottom section, corresponding with the whole degrees, would be the whole circumference of the circle, which is either going to be pi d or 2 pi r. Okay, so you just relate part to whole. Part is the arc length, and whole is the circumference. So let's actually do number 4, where it says that we're going to find out the arc length, the length of arc of this section containing daffodils. So that would be this section right here. So we need to know what angle this is here. So think about that. Think about what that angle is. Okay, so our part degrees of the circle would be 65 degrees. 65 degrees. What's our whole degrees of the circle? 360 degrees. We will find our arc length here, and pi d would be pi times a 15-foot diameter, and there you go. So if I want to solve a proportion that looks like this, I would like for you to go ahead and leave things in terms of pi. That means you're going to solve it and leave pi in your answer. So we're going to do 65 times 15 equaling 360x. And so then, of course, we would divide by 360 because this is our 15 pi here. So x is going to be, and if I divided 65, or I multiplied 65 times 15 divided by 360, I believe I get 2.71, and you may leave it in terms of pi. Some of the problems on the tax test will leave things in terms of pi. Some of them will um, go ahead and change it. Some of them will tell you to use 3.14. Some of them will go ahead and change it, and then some of them will want you to use the pi button. So if you're going through a problem and those numbers are a little different than what you came up with, they probably use the pi button and not 3.14. Okay, so that's arc length. Now let's go on to the next section, which is sector area. Sector area would be saying, okay, I want to know how much area this is taking up this pizza slice here. Okay, so I want to find out the area of this, not just the little piece of string going around the edge or the edging going around the edge. So we're finding the entire amount of cheese covering that slice of pizza. All right, so what is the sector area? Well, we're going to use the same idea of part over whole. Part degrees to whole degrees. The difference is that since we are doing the sector area as our part, we want to compare it to the area of a circle, and the area of a circle is pi r squared. So that is the only difference on this formula versus the other formula. The other formula, we were finding arc length, so we use circumference. Here we're finding area, so we use area formula. So let's do this problem. Our part is 70 degrees out of our whole degrees of 360. Our sector area we don't know, and our circle area would be pi r squared. So we solve that by doing 70 times 9 pi equaling 360x divided by 360. So x is 1.75 pi, and you can leave that in terms of pi. All right, so that is all on those circles. I think by doing that, you can handle all of that on those circles. I just wanted to go ahead and summarize let's go ahead and summarize what we're talking about here. So let me pull up a blank sheet so I can write that up there. And I'll have a blank sheet. So in summary, if you are finding your arc length, then you're going to do your part over whole to the arc length over circumference. Okay? But if you are doing sector area, this is the cheese on this pizza. If you're doing sector area, you're going to do part over whole. And you got the sector area over pi r squared. So as you can see, the only difference is choosing either this circumference formula or this area formula right here. And that is the notes on circles, arc lengths, and sector areas.